Hello, grade 12s. Ngiyanibingelela. Ngiyathemba niyaphila emakhaya. All right, today I want us to talk about photoelectric effect, a topic under optical phenomena. And properties of materials. So if photoelectric effect is a subtopic under optical phenomena and properties of materials. So first thing mele understand what is photoelectric effect. Let me demonstrate by this small diagram. I hope you will see, you guys. All right, let me say this is a material and this material is a metal. Okay, and you know this metal is having its composition. Okay, first thing first, the word photo has to do with light. Then electric has to do with electricity. So I think there is a light here and electricity involved, but I will explain that later. Let's say now there is this light rays, or let me say these lines represent the light. Okay, this is the light. This is the light, and you know light is moving like waves. And then here, this is the surface. That's the surface of this material. Okay, yes. So this material is having its own work function. I'll say W subscript O. In other words, I mean to say this is the work function. Okay. Here we have let me say these are the negative things there. Let me say electrons. Okay, so this light will shine on the surface of this material or this metal. Okay, as that process happens, the electrons here will be removed. The electrons here will be removed, meaning to say will be ejected, meaning to say will be emitted. Okay, remember this WO or this W subscript, this sub W subscript O, that is the work function. In other words, this is the minimum energy that the electrons need to be ejected from the surface of this material. Okay, so let's understand one thing here. If this light is incident on the surface of this material and the energy there is less than this work function, if the energy or incident energy is less than the work function, we must understand one thing here. No electrons will be ejected. Okay, no electrons will be ejected. So okay, so let's say now this light is having enough energy, and if now we say E is the energy of the incident light, therefore this light must have an incident frequency. Okay, so that means the incident frequency of the light, or we can also say again here, if the incident frequency is less than the threshold frequency, no electrons will be ejected on the metal surface. All right, let's assume now the incident energy of the light, or the energy of the photon, is greater than work function. Also, the incident frequency is greater than the threshold frequency. Therefore, in this case, electrons will be ejected. So ejected, emitted, all those terms means electrons will be removed from the surface of this material or this metal. Okay, so now let's say, like I said, let's say now this is the second case. Let's go with the second case. Now we say the incident energy is greater than the work function. So in that case, electrons will be ejected. So if that's the case, the electrons now will have maximum kinetic energy. Okay, now they move from the surface, and then they will move with the since the electrons are moving, that means they possesses kinetic energy, and that kinetic energy now we say it is maximum. Okay, so that means here we're going to have a maximum kinetic energy of the electrons. Okay, so that means we can have an equation here. You see the E over here, we said that's the incident energy or energy of the photon. We can write now and say E is equal to work function plus maximum kinetic energy. So that means this is the energy of the photon. Okay, this is the work function of the material. Okay, and then this is the maximum kinetic energy of the photo electrons, maximum kinetic energy of photoelectrons. So what can we say in all? In other words, photoelectric effect is the process whereby the electrons are ejected when light of suitable frequency is incident on that